So this is actually one of the bridges that I've built with Science Olympiad, and this is one of the tests of them. And the beginning is in fast motion, but the next couple seconds is in slow motion. So you can see actually where I'm talking about in the video, where the load is applied and all that. Hello, this is my This is my TED Talks presentation. My presentation is how does Newton's third law relate to bridge building? So first off, Sir Isaac Newton came up with three laws of motion. The first law was that an object at motion tends to stay in motion unless acted upon by an unbalanced force, and that applies to an objects at rest. They tend to stay at rest applied by unless an unbalanced force is applied to them. That is a law of inertia. Newton's second law was force equals mass times acceleration. Now, Newton's third law was every action has an equal but opposite reaction. This is the law we will be relating to bridges in this TED Talk. The topic we'll be exploring is in this TED Talk is how Newton's third law relates to a bridge breaking. Also, we will explore how a load's angle coming on the bridge can change how a bridge can perform. So, how exactly does Newton's third law relate to bridges? There is a way Newton's third law applies to bridges. When a load is applied to a bridge from the top, the bridge applies a force back onto the load. That is based on the build of the bridge and what material are used to build the bridge. There is a limit to how much weight a bridge can hold. A bridge stays intact when a load is applied to it because it depends on the bridge's ability to send back as much force as it is receiving. A bridge holds force because of its ability to send a force back to the load. A bridge that has a good capability of sending a force back and holding the load will be a successful bridge, but a bridge that can't send force back to the load or react will fail easily. So what is the action and reaction in this process? The action is the load coming on the bridge, and the reaction is the bridge sending a force back. There is one main variable that is in this process. The main variable is the angle of where the load is being applied on a bridge. The variable is to change the angle of the load coming on the bridge and see if the bridge fails or keeps going. That would depend on what side the load is going. Whichever side the load is going, that is the side that will feel the most pressure. That side will be holding the entire load while the other side will be doing nothing. So, let's say a bridge has the potential to hold, let's say 10,000 kilograms. If the load is off-centered or very close to the side of the bridge, then the bridge will only have maybe even half or even less than half of its full potential of holding that mass. So the bridge might only hold only 2,000 or 2,500 grams. That's because all the pressure is going on one side of the bridge. For one side of the bridge, as you can see here, one side of the bridge here, and all the pressure is going there, and that can really break your bridge. If the load isn't placed in the center, then the bridge will be able to hold then the bridge will be holding its max potential, and the force will be directed. The action force will be directed through both legs, and the bridge will be able to support that load upward, and the bridge will have a greater capability of sending a force back up to the load because the load will be coming up on here on the top. And that's how this bridge relates to the third law. Here are some here are some efficiencies and experiments that I did with the bridge, and these are my graphs for it. When a load is applied closer to one leg, let's say on try number 1, the distance from the center of the bridge was 4 centimeters, and that carried 4,000 that carried four that only carried 4,000 grams of sand. The efficiency was 800. That was because it was a 5-gram bridge. When on try number 2, I did the distance from center was 3 centimeters, and the load carried was 6,000. So as you get closer to the center, the load is actually more divvied up into the bridge. So it's easier. So the bridge can hold more. And that efficiency was 1,200. On try number 3, I put the distance from center was 2. That load carried 7,000 grams, and the efficiency was 1,400. Now on here, I kept the load on center, and I measured the weight, but it came at I did it 3 times, and the efficiency came differently all 3 times. On the first try, the load carried was 13,500 grams. So you can see it makes a big difference when the angle of the load is in the center of the bridge, and the efficiency of that was 2,700. On the try number 2, the load carry was 12,500. That was 2,500 efficiency, and on try 3, it's 12,000. It held 12,000 grams, and the efficiency was 2,400. So you can see that as it's closer to the center, as the load is closer to the center, the load is more divvied up, and the bridge can easily exert a force more up into the load. Okay, that's my TED Talk. Thank you.